Hello everyone, my name is Matt Poliszczuk, and in this video I'll be going over the MEXT Undergraduate 2019 Math B exam. So the way this will work is for every question I'll start by just telling you what you need to know to be able to answer it so that you can try it on your own, and then I will go through the detailed step by step. But before that though, I just want to mention a few things about the exam that I think are important to know. So it's written on the exam that of course is 1 hour long, and you cannot bring a calculator or any other tools, just writing utensils. One thing that I didn't know when I went to write the exam is that they do not give you any extra writing space. No scrap paper, nothing like that. And in my case, at least, I don't know if it's always like this, but for me, the exam was printed on both sides, so I didn't even have like the blank back of the page to work on. So the only space you have to work is in the margins of the exam sheet itself, sorry. So when you're practicing for this exam, make sure to keep in mind that you only have a little bit of space to do your work. Also, as far as I am aware, they only look at your final answer for every question. They don't look at your work, and they won't give you any like part marks or anything if you did some things correct but did not get the correct final answer. So that means it's really important to be careful and accurate and to make sure all your steps are correct, because if you make just one small mistake on a question, you can get the final answer wrong and lose 5 or 10%, or maybe even more if it's one of the larger multi-step questions. Of course, the time limit is pretty strict with only 1 hour, but still, in my opinion, it's better to be careful and make sure you get your answers right than it is to rush things and possibly get no marks on questions that you knew how to answer, but you just made a small error. So with that out of the way, let's start with the first question. So the total number of positive divisors of 2019 is blank, and the whole sum of those divisors is blank. So this question isn't very difficult, it's just finding factors of a number. It's probably the kind of thing that many of us did back in like middle school and haven't really thought about it in a while. The real tricky part of this question is doing it quickly and also making sure you don't make any mistakes. Because if you miss a factor or make an error when summing them up, you can lose a lot of marks. So it's really just about being fast and precise. So for a question like this, the first thing you want to do is find the prime factorization of the number, in this case 2019. This is when you find all the prime numbers that multiply together to make 2019. And the reason why this is important is because once you have found the prime factorization, you can combine those prime numbers together to find all the factors of your number. So for example, here's the prime factorization of 100. You start checking from the lowest prime, which is 2. 100 is divisible by 2, so you get 50. 50 is also divisible by 2, so you get 25. And 25 is divisible by 5, so you get 5 and 5. So you're left with only prime numbers, which means you're done finding the prime factorization. And here you can see that I combined the prime numbers together in different ways to find all the factors. So of course 2 itself is a factor, and if you multiply 2 by 2, you get 4, which is another factor. 5 is a factor. 5 times 2 is 10, which is a factor, and so on. So if you do all the different combinations of prime numbers, you can find all of the factors. So here I have all the factors of 100 listed. I like to arrange them starting from the bottom with the number that factor multiplies by to get the original number listed next to it. So 1 is a factor and it multiplies with 100, which is another factor. 2 is a factor and it multiplies with 50. 4 is a factor and multiplies with 25, and so on. So hopefully this makes it clear why we want to find the prime factorization of the number. So let's go back to the question which asks us to find the factors of 2019. So let's check for prime factors starting from the smallest. So 2 is clearly not a factor since 2019 is an odd number. 3 is a factor of 2019, and there's a very easy trick to figure this out. If you add up the digits in a number and that sum is divisible by 3, then the number is divisible by 3. So 2019 is 2 plus 0 plus 1 plus 9, which equals 12. 12 is divisible by 3, so 2019 must be divisible by 3. To find the number that you multiply 3 by to get 2019, of course, just divide 2019 by 3. If you're really good at mental math, then of course you can just do it in your head. But personally, I recommend taking your time and making sure you get it right. So here you can see I did the long division to get that 2019 divided by 3 is equal to 673. Remember, they only look at your final answer. So if you rush this step and you get the wrong number, you could get the entire question wrong and lose 10%, which is what this question is worth. So it's better to take a bit of extra time to be extra careful. So now I want to try finding factors of 673. Again, we start from the smallest prime and work our way up. So I'm going to write these out. So, 2 Clearly 2 is not a factor of 673 because this is odd. 3 is also not a factor because if you add up these digits in 673, 6 plus 7 plus 3 adds up to 16, which is not divisible by 3. 5, clearly not, because 673 doesn't end in a 5 or a 0. The next prime is 7. So there are some tricks to figure out if a number is divisible by 7 and 11 and 13 and so on, all the prime numbers. But I don't think you should bother trying to learn those for this exam, unless you have like a lot of time to study. Instead, you can pretty quickly check mentally, or if you want to be really careful, you can do a quick long division and see if there's a remainder. The way I check for it goes like this. So 7 goes into 63, which means it must also go into 630. I then add 7s to 630 to see if I can add up to 673. So 630 plus 7 is 637, 644, 651, 658, 665, 672, and 679. So we've skipped over 673, which means 7 is not a factor of 673. Okay, so let's go to the next prime number, which is 11. So again, I do a similar trick. 11 goes into 66, which means it must go into 660. Add 11s to that, so 671, 682. We skipped over 673, so 11 is not a factor of 673. So now at this point, you might be thinking, okay, so how far do we have to go with this? How many numbers do we need to check? And actually, there's a very useful trick to know when you're done, and you can stop checking for factors. So to explain, let's go back to the factors of 100 that I found over here. Starting from the smallest number 1, I check all these other numbers to see if they are factors. So 2 is a factor, 3 isn't, 4 is, 5 is, so on until I get down here to 10. Okay, so 10 times 10 equals to 100. Now let's say I want to check if 11 is a factor of 100. So 11 times 10 is clearly bigger than 10 times 10, which means that if I make one of these 10s an 11, I must make the other 10 smaller. Let's say make it a 9, just for it to have any chance of equaling to 100, right? But here's a crucial thing. I already checked all of the numbers that are smaller than 10, right? I already checked 9 and 8 and 7 and so on. So that means that there is no point in checking the numbers bigger than 10, since I'll just be checking for factors that I already checked previously. So that means I'm done and I've already checked for it and found all the factors of 100. Of course, you might have noticed something special, which is that we stopped at 10, which is the square root of 100. That's the important part. When checking for factors of a number, you only need to check up to its square root, assuming you start from 1 and go up and work your way up. If you go past the square root, you will be checking for factors that you already checked for previously. So if we go back to our question, that means we have to check for factors up to the square root of 673. Now, what is the square root of 673? Well, it's kind of hard to figure that out, but you don't really need to. You can just guess, really. So let's just list a few more prime numbers here. So we have 11. Okay, let's do 13, 17, 19, 23, 29, and 31. Okay, let's stop there for now. Okay, so let's consider 31. So 30 times 30 equals to 900. Since 3 times 3 equals to 9, you add 2 zeros. That's, of course, much bigger than 673, which means we definitely don't need to check 31. That's it. 29 times 29 is a little bit less than 30 times 30, which again is way bigger than 673. So you can pretty safely assume that 29 times 29 is bigger than 673, and you don't need to check it. Of course, if you want to be really careful, then you can just quickly right here multiply 29 times 29 and find that it is in fact far greater than 673, which means you don't need to check it. So the next prime less than 29 is 23. Just looking at it, 23 times 23 is a lot smaller than 29 times 29. So you probably do need to check 23. Again, if you want to be extra sure, you can multiply 23 times 23 and find that it is in fact less than 673. So you have to check it. So there we go. We need to check if 673 is divisible by all prime numbers up to 23. Now, if you're wondering why we're only checking for primes, it's because by checking for prime factors, you are effectively also checking for non-prime factors. So for example, for a number to be divisible by 4, it must be divisible by 2. So once you check that if it's divisible by 2 and found that it isn't, there's no need to check if it's divisible by 4. Another example is, say for a number to be divisible by 10, it must be divisible by 2 and 5, since 2 times 5 equals to 10. So if you already found that your number is not divisible by 2 and or 5, then it's not necessary to check if it's divisible by 10. So let's keep checking if 673 is divisible by prime numbers up to 23. I'm not actually going to do all of these. Like I already explained you guys the process that I usually use before. You can check all of these with mental math, or if you want to be really careful of long division. And you'll find that 673 is not divisible by any of these prime numbers, meaning that 673 is itself a prime number. So we're done. We have found all the factors of 2019. They are, let me actually list them. They are 1, 3, 673, and 2019. And of course, the question asks us to find the total number of positive divisors, which is 4. And then if we sum up those numbers, we get 2696. So that is the final answer. So yeah, this question isn't that hard, but it is designed in a way to really test your patience, right? You need to be really careful and accurate when answering this, because if you make a single small mistake, then your final answers can be wrong and you won't get any marks. So it's definitely, in my opinion, worth going a bit slower and making sure all of your calculations are perfect instead of rushing and potentially making a mistake. So next is question 2, which says, for the 3 points O is 0, 0, A is 3, 0, and B is 3, 4, on the xy plane, the equation of the angle bisector of angle AOB is y equals to blank x. And in case you didn't know, angle bisector is when you cut an angle in half. And here where it says angle AOB, it means the angle between the lines connecting A and O to B. And because it's asking for y equals to blank times x, they're asking for an equation of a line that cuts this angle in half. So it would look like this. Also, in general, whenever you get a question that talks about points or shapes or anything like that, I highly recommend drawing a diagram, so something like this one. At least a small one like this, it can really help give some sense to the question. So now to solve, the first thing you might think is this. So if you want the line to cut this angle in half, then you can make it go through the midpoint of this line that connects points A and B. So it would look something like this. And it would go through this midpoint, which would be from 3, 0 to 3, 4. That would be 3, 2. But that's not exactly correct. And the reason why is because this line connecting O and A is a different length than this line connecting O and B. So cutting the angle with a line that goes through the midpoint here will not actually give you the angle bisector. It will only do that if these two lines, OA and OB, are the same length. So we need to find the length of these lines. So thankfully, because they start from the origin, it's pretty easy. Sorry, my app got a bit weird. Let me erase this. Yeah, so since they start from the origin, it's pretty easy. Line OA goes from 00 to 30, which means its length is clearly 3 units. And line OB goes from 00 to 34. So we can use Pythagorean's theorem to find that this line is 5 units long. So that means that to make the two lines the same length, we want to extend OA all the way to 50, which I did over here. And I labeled that new point right here as C. So now we can make a line between points B and C and find the midpoint of that line, which is right here. And again, it's thankfully pretty easy. So the x value changes from 3 to 5. So the midpoint for the x value is 4. And the y value changes from 4 to 0. So the midpoint of the y value is 2. So this point is 4, 2. So now if we make a line that goes through point O, And also through this new point that we found, 4, 2, it will in fact bisect this angle right here. It will cut it in half. So the question asks for a line in the form of y equals to blank times x, meaning they're only asking for the slope of this line. So in order to find that, the easiest way is, of course, rise over run. So right here, m equals to rise over run. So the rise is from 0 to 2, which is just 2. Oh, let me draw that a little bit nicer, which is just 2. No, okay, that looks the same, but whatever. Hopefully you guys know that's a 2. And the run is from 0 to 4, so it's 4. So the slope of this line is 2 over 4, or of course simplified 1 over 2. And so that means that the equation of this line is y equals to 1 over 2x, which is the final correct answer. Question 3, which says, for parabola y equals x squared and 2 points -1, 1, and 3, 9 on it, its tangent line parallel to the line through the 2 points is the line y equals to blank x plus blank, whose point of tangency is the point blank comma blank. So for this question, you need to be able to find the derivative of a parabola y equals x squared and know that the derivative of a function gives you the slope of the tangent line to that function at that point. And you need to know the point slope form of a line. So here, x1 and y1 are a specific known point on a line, and m is the slope of the line. There are ways to solve the question without this form, but I think this is the easiest. So once again, just like the last question, I recommend you start by drawing a diagram. So here I drew the parabola y equals x squared in green, and I labeled the 2 points that they gave us, -1, 1 and 3, 9. I then drew this line between them, since the question asks for the tangent line parallel to the line that goes through these 2 points. This second line right here is the tangent line, which I just drew, based on what roughly seemed like the right spot for it to be parallel to the first line. And the question also asks for the point of tangency, which means the point on the parabola where the tangent line is parallel to the line through these 2 points. And I labeled the point of tangency as point P right here. So because I want to find a parallel line, the first step is to find the slope of the line through the 2 points, which I did right here. So using rise over run, we see that the slope of the line is 2. That means we want to find the point on the parabola where the tangent line has a slope of 2. So the first derivative of a function gives us a new function that tells us what the slope of the tangent line is. Using the power rule, we find that the first derivative of our parabola is equal to 2x. We want the slope to be equal to 2, which means we want 2x to be equal to 2. So x equals to 1. This means that at x equals to 1, the slope of the tangent line to the parabola will be 2. This also means that x equals to 1 is where we find our point of tangency. If we plug x equals to 1 into the function of the parabola, right here, then we find that the point of tangency is 1, 1. So that's 1/2 of our question complete, right here. Now we need to find the equation of the line. The easiest way to do that, in my opinion, is to use the point slope form of the line. So right here, we know a point on the line, as we just found that the point of tangency is 1, 1. We also know the slope of the line m is equal to 2. So if we plug in those values right here, and then rearrange a little, we find the equation of the line is y equals to 2x minus 1, and that is the second half of the answer to this question. Question 4, which says, when the line y equals to m x minus 5 plus 3 intersects the circle x squared plus y squared equals r is greater than 0, if and only if 0 is less than or equal to m, which is less than or equal to blank, r is equal to blank. So for this question, you firstly need to understand what exactly it's saying, which at least for me was a bit of an issue. When it says if and only if, it means that the conditions given must always be true for the values of m and r. What that means is, for the r value that you come up with, your range of m values must make lines that always intersect the circle and there is no part of the circle that is not being intersected by the line. And if that doesn't make sense to you now, that's fine. I'll explain it in more depth in a bit. Also, there's a last part of the question which has multiple ways of solving it, but in my opinion, the easiest is to use this right here, which is the equation to find the distance between a point and a line. This is a pretty useful equation in general and actually helped me a lot when I wrote the exam in 2025, so I recommend learning it. So we have, d is the distance, we have our line, which is in, I believe it's called standard form, ax plus by plus c equals to 0, and we have the point, which is just x1, y1. If you plug in these values here, so distance is equal to the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. You can use this to find the shortest distance between a point and a line on a Cartesian plane. So once again, I recommend drawing a diagram, which I did right here. So I made this one. So to start for a question like this, it is always a good idea to check the extremes or the endpoints of the range. So in this case, the question says that m is greater than or equal to 0. So it's a good idea to plug in m equals to 0 and see what we get. So for m equals to 0, the line just becomes y equals to 3. So this is just a flat horizontal line that is always at y equals to 3, which I drew here in blue. Now let's try a different value of m and see what happens. So if you try m equals to 1, then you end up with the line y equals to x minus 2, which I drew here in green. So now the line is not flat. Instead, it travels from the bottom left towards the top right. And you will see that as you make m bigger, you will get a line that is steeper and steeper, as shown, for example, by this red line right here, which is when m equals to 2. So when m equals to 2, you get y equals to 2x minus 7. So the slope becomes greater, right? Before it was 1, now it's 2. And also the y-intercept becomes more negative, which means it intersects the y-axis at a lower point, as you can't even see here, right? It's cut off. But eventually it would intersect, but it would intersect much lower than the green line, which intersects at -2. So, but basically what's important to notice is that the slope will always be positive, since m is given as being greater than or equal to 0. So you never have a line that goes from the top left to the bottom right, like this, for example. You can't have a line like that because the m value, based on the question, must always be greater than 0. So you cannot have a negative slope like this. And you may have also noticed something else here, which is that no matter what m value you choose, at x equals to 5, y equals to 3, right? So because if you have x equals to 5 here, just 5 minus 5, this becomes 0, and so it's always just y equals to 3. And so all of your lines, regardless of the m value, will go through the point 5, 3, which, is this point right here. So this point right here is 5, 3, and all of your lines will always go through this point, regardless of what m value you choose. So why is all of this important? Well, remember that the question says if and only if, which means that the circle, which will have a certain radius, must always be intersected by the line. So let's look right here. So here we have our line y equals to 3, which happens when m equals to 0. So let's say we draw a circle with radius 4. So let's draw it like this. So okay, that looks really terrible, but you guys can trust me when I say that this radius is equal to 4. So we previously determined that our line can only have a positive slope, which means the other values of m that we use can only make lines that look, something like this. They can look like that, right? Remember they all go through the same point, but they'll look, something like this. So as you can see, no matter what value of m we choose, this part of the circle right here, this part up here, will never be intersected by the line. And the question says if and only if, so that cannot be permitted. All parts of the circle must be intersected. So a circle cannot go above the line y equals to 3, which means that the radius of the circle must equal to 3, which is the first part of the answer to this question. So we found that the radius of the circle must equal to 3, because if you make it greater than 3, then the part of the circle above r equals to 3 will not be intersected by any of the lines. So we now know that r equals to 3. So I was going through the video and I realized that the diagram I made kind of made this part look a little bit more complicated than it needed to. So I remade it here a bit neater, and hopefully this can clear up some confusion if you had any. So we already determined that the circle must have a radius of 3. And we also determined that all of our lines must go through this point, 5, 3. And our line must have a positive slope, so it either goes fully horizontal like this, or it goes from bottom left to top right. We cannot have a line that goes from top left to bottom right like this, because we know that our m value must be greater than 0, because that's given the question. So because of this, if you just draw this, you'll see that the other m, like the bound for our m, which is this line right here, definitely has a positive slope, right? If the circle was bigger, or if our point 5, 3 was more to the left, so let's say instead of 5, 3, let's say the pivot point was 2, 3, which would be somewhere around here, then the m value that would bound the circle would look something like this, and it would actually have a negative slope. And so that would make the question a lot weirder. But in this case, because we know that the line goes through the point 5, 3, regardless of the m value, we know that the bounding m will still have a positive slope. So hopefully that makes sense. I know the diagram I made in the last section kind of didn't make that obvious. Hopefully now you can see what I'm talking about, and this question is a bit clearer. So now that we know the size of our circle, we can draw another diagram that includes it. Or, of course, as I mentioned before, you don't have a lot of space in your exam because they don't give you extra space. So you'd probably just want to, add to the diagram you already made. But in this case, because I have space, to make it clear for you guys, I'm going to draw a separate diagram. So here we have our upper bound line, y equals to 3. We then have our circle here with a radius of 3. And we have our second line here, which has the m value that is our other bound, which is what we're trying to find. So you can see it just touches the circle at one point here, meaning it is tangent to the circle. And if you made the m value any greater, it would no longer touch the circle at all. So now there are definitely a few ways to solve for the m value here, but in my opinion, as I mentioned before, the easiest is to just use the distance from a point to a line equation. So firstly, we need to put our line into this form, or like the standard form, sorry. And we end up, as you can see, I expanded here, we end up with mx minus 1y plus 3 minus 5m equals to 0, which means our a value is equal to m, our b value is equal to -1, and our c value is equal to 3 minus 5m. And as for our point, well, if we look at our diagram, you'll see we're trying to find the distance between our line and the center of the circle. And since our circle is centered at the origin, our point is just 0, 0. Also, we already know the distance that we're trying to find, right? It's the radius of the circle, which we found to be equal to 3. So we know our distance is equal to 3. So we plug in all our values and we end up with this equation right here. So I'm not going to explain all this expanding stuff because it's pretty straightforward. Of course, you can pause the video and look at it if you want. But you will see that we end up with two m values. So first one is 0, which we already know. And the second one is m equals to 15 over 8, which is our other value and the second part of the answer to this question. So to be clear, what we found here are the values of m such that our line will be exactly 3 units away from the circle from the center of the circle at its closest point. So the first one is when m equals to 0, which is just this blue line here, and of course it is exactly 3 units away. This is 3 at its closest point. And then the second one is 15 over 8, which is the m value for our line over here. So when m is equal to 15 over 8, this line is also at its closest point is exactly 3 units away from the center of the circle. And that is the answer. So next is question 5, which says, when the absolute value of x is less than or equal to pi over 2, the maximum of sine x plus cosine x is blank, and the minimum of that is blank. Before I start answering this question, I want to explain a really important concept that will be very useful for answering questions like this. And these sorts of questions come up pretty often in the MEXT practice exams, so it's definitely important to understand. So take a look at this parabola, which is just y equals to x squared. Now, what if I asked you to find me the minimum and maximum values of this parabola? For the minimum value, you can probably figure out that it's right here, which is when, which is when x equals to 0 and y also equals to 0. For the maximum, I mean, it doesn't make sense really, right? Because the parabola just keeps growing more and more, so there really isn't a maximum value. But now, let's say I draw these two lines, like this, and I ask you to find the minimum and maximum values of the parabola between these two lines. So now it makes more sense to find the maximum value. It's clearly right here at this bound, and the minimum is still at 0, 0. So one of the maximum or minimum is at one of the given bounds. Now let's change one of the bounds and make it look like this. So now the minimum is clearly right here at this bound, and the maximum is right at this other bound. So both the minimum and maximum are at the bounds given. So in general, if a question asks you to find the maximum and minimum of an equation within a given bound, you should always start by checking those bounds, or checking the x value of those bounds. Because there's a good chance that at least one of those values, either the minimum or maximum, is at one of the bounds. As another quick example, here's a sinusoidal function, y equals to sine of x. The minimum and maximum values here are of course just -1 and +1. But if I add bounds like this, for instance, then the minimum and or maximum values change. They're now whatever the value of the function is at these bounds. Unless, of course, over here, right here, the minimum might be, not actually at the bound, but in the middle. But in general, there's a good chance that one of these two bounds will have either the minimum or the maximum, especially if they're asking a question like this, right? It's just kind of, for a question that asks you for the minimum maximum value of a function between certain bounds, it's kind of just, questions like that are kind of designed for you to check the bounds and have at least one of those values be at the bounds. So with that out of the way, let's get to the actual question. So for this, of course, you need to understand how trigonometric functions work, how to check for the values of common angles in trigonometric functions, and how to find and use the derivative of a trigonometric function. So the question says, when x is less than or equal to pi over 2. So we already have our two bounds for the x value, which is x equals to pi over 2 and x equals to negative pi over 2 and x equals to positive pi over 2. So we can start by checking the value of the function at these x points. So when x equals to negative pi over 2, then we get -1, since sine of negative pi over 2 equals to -1, and cosine of negative pi over 2 equals to 0. And then when x equals to positive pi over 2, then we get +1, since sine of pi over 2 equals to 1, and cosine of pi over 2 equals to 0. So we've checked our two endpoints that we have found are possibly the minimum and maximum values, but we're not done yet. So let's go back to the sine function, and as you see, our bounds are like this, and you can see that in this case the maximum right here is at an endpoint, but the minimum is actually in the middle. It's right around here somewhere. So for this question, even though we've checked the endpoints, we could still have a maximum or minimum in the middle. And to check for this, we need to use the derivative of our equation. And thankfully, this is just a very basic trig derivative. And so we find over here that since y equals to sine x plus cosine of x, the derivative of y equals to cosine of x minus sine of x. And we want to make this equal to 0 because that is the point at which our function has a slope of 0, which is where there's usually a local minimum or maximum. So again, looking at our sine function, at this point right here, the slope, so this point right here, the slope is equal to 0, and you can see that it is at the slope is equal to 0, because the tangent line is just horizontal, and you can see that this is a minimum. And over here as well, you can see the slope is equal to 0 because the tangent line is just horizontal, and that is a maximum. So we set our derivative equal to 0, and we find from that cosine of x equals to sine of x. And that happens when x is equal to power of 4, which is, I guess, just something you kind of have to know. It's a pretty basic fact about trigonometric functions. So at x equals to power of 4, the original equation has a tangent of 0, which means it is probably a maximum or minimum. Also, normally for a trig equation like this, you need to check for other x values that satisfy this equation, cosine of x equals to sine of x. But here, the only way to do that would be to add or subtract 2 times pi to this value of pi over 4, which would be outside of the bounds given in the question. So pi over 4 is the only value that we need to consider. So now we plug pi over 4 back into our original equation. And we get sine pi over 4 plus cosine pi over 4, which equals to 1 over the square root of 2 plus 1 over the square root of 2. And then if you simplify a bit, you end up with this equaling to the square root of 2. So previously, we found that the bounds have values of x equals to 1 and x equals to negative 1. And now we found that there's a maximum equaling to the square root of 2 inside of the bounds. So our maximum is equal to the square root of 2, and our minimum is equal to negative 1, and that is the answer to our question. Also, if you have trouble memorizing the common angle values, here's how I do it. So I draw these triangles. So the first one right here has 2 sides of length 1 with a square angle in the middle. And then with Pythagorean theorem, you find that the hypotenuse is equal to the square root of 2. And the angles inside are 45 degrees, or pi over 4. And then, of course, sine equals to opposite over hypotenuse, cosine equals to adjacent over hypotenuse, so on. And so you can use this to find the values for the angle pi over 4 inside a trigonometric function. And then this triangle over here gives you the values for the angles pi over 3 and pi over 6, which are 60 and 30 degrees. So what I do is I draw half of an equilateral triangle with side lengths of 2. So this side has a length of 2. This side is only 1, since it's only half, right? It's only half the triangle. And then this side is from the Pythagorean theorem, you find that it's equal to the square root of 3. So an equilateral triangle always has angles of 60 degrees, or pi over 3. So this angle right here is pi over 3. This angle right here is pi over 6, since we cut the triangle in half. And then, of course, this right here is a right angle, since, again, we cut the triangle in half. And then from this, you can find the values of, sine pi over 3, cosine pi over 3, sine pi over 6, cosine, and so on. So hopefully that helps. So next is question 6, which says, by log base 10 of 2 equals to 0.3010, and log base 10 of 3 equals to 0.4771, the number of digits of 6 to the power 100 is blank, and its leading digit is blank. So this is probably the hardest question on this entire practice exam, and also I had a question like this on my exam when I wrote it, so it definitely seems like they like questions like this, so I think it's pretty important that you understand it. So for this question, the only things that you need to know are the logarithm addition rules and the log power rule, or maybe the log times a constant rule. But these are 2 basic log rules that you should definitely learn anyways if you don't already know them, along with some of the other basic log rules, which you can easily find online if you just search up basic log rules. You also technically need to know just like the way an exponential function looks and a logarithmic function looks, but we'll get to that later. So, but again, this question is really hard, so don't feel too bad if you can't figure it out on your own. So the question wants us to give information about the value of 6 to the power 100. Firstly, you should notice that this value is, of course, way too big to work with normally, especially since we don't have a calculator for this exam. So instead, we need to use these provided log values. So because we have 6 in the base, the first thing we can do is use the provided log values to find log base 10 of 6. So with the log addition rule, we can add the logs of 2 and 3 to find the log of 6, since 2 times 3 equals to 6. And so we find that log base 10 of 3 equals to 0.7781. Also, from now on, I'm probably not going to say base 10 to save my breath, but it will always be base 10 unless I state otherwise. So, of course, we're looking for 6 to the power 100, not just 6. So here we can use another common log rule, which says that log of 6 to the power 100 is equal to 100 times log of 6. And of course, we just found that log of 6 equals to 0.7781. So 100 times that is just 77.81. And because log is just inverse exponential, we can say that 6 to the power of 100 equals to 10 to the power of 77.81. And you'll find that this is a much easier value to work with. So first we can break this up into 10 to the power of 77 times 10 to the power of 0.81 and look at these individually. So 10 to the power of 77 is just a 1 followed by a bunch of zeros. More specifically, it's a 1 and 77 zeros. So, for example, 10 to the power 1 equals to 10, which is 1 0. 10 to the power of 2 is 100, which is 2 zeros, and so on. So this number has a 1 and 77 zeros for a total of 78 digits. Now, what about the other part, which is 10 to the power of 0.81? So, well, consider the fact that this is clearly greater than 10 to the power of 0 and less than 10 to the power of 1. So this, of course, then means that it is greater than 1 and less than 10. So it is a one-digit number. So now we have 10 to the power of 77 times this number. And 10 to the power of 77 is, of course, just 1 followed by a bunch of zeros. The important thing to notice here is that when you have a number that is just 1 followed by zeros, and you multiply that number by a one-digit number, the number of digits does not change. So for example, if you have 1,000, which is 4 digits, and you multiply it by 5, you get 5,000, which is still 4 digits. And if you multiply it by, say, 9.99999, so on, you get 9,999.99999, which is still 4 digits. And since we know that 10 to the power of 0.81 is a one-digit number, we know that multiplying 10 to the power of 77 by it will still not change the number of digits. Therefore, we know that 6 to the power of 100 has 78 digits, which is the first part of our answer. So what about finding the first digit of 6 to the power of 100, which is the second part of the question? So we can start by thinking back to our previous example where we multiplied 1,000 by one-digit numbers. So you'll notice that the first digit of the new number is the same as the first digit of the number we multiplied 1,000 by. So 1,000 times 5 equals to 5,000, so the first digit is 5. 1,000 times 9.99999 is 9,999.999, so the first digit is still 9. So that means that to find the first digit of 6 to the power of 100, we need to find the first digit of 10 to the power of 0.81. So to start, let's return to when we found log base 10 of 6, which equals to 0.7781. We can use this to say that 10 to the power of 0.7781 equals to 6. The number we're looking for, 10 to the power of 0.81, is clearly bigger than 10 to the power of 0.7781, so it is clearly greater than 6. So 10 to the power of 0.81 must start with a 6, a 7, an 8, or a 9. So now I want to try and narrow this down a bit more. And what we can do is we can use log base 10 of 2, which is provided, and add it 3 times to get log base 10 of 8, since 2 times 2 is 4, and 4 times 2 is 8. So we get that log base 10 of 8 is equal to 0.9030, which means that 10 to the power of 0.9030 is equal to 8. And of course, 10 to the power of 0.81 is less than 10 to the power of 0.9030, so 10 to the power of 0.81 is less than 8. So we have narrowed it down so that 10 to the power of 0.81 is greater than 6, but less than 8, which means it must start with either a 6 or a 7. So of course the final question is, does it start with a 6 or 7? So the first way you can answer this is really, you can kind of just guess. I mean, if you look at it, 0.81 is much closer to 0.7781 than it is to 0.9030. So it's probably much closer to 6 than to 8. So it probably starts with a 6. And that would in fact get you the right answer. But if you want to know for sure, there is a way to get the answer without any guessing. So to start, let's find the halfway point between the exponents that get 6 and 8. So to do that, we add them together and then divide by 2. And we get 0.8405, which is greater than 0.81, which means that the exponent of our number, 10 to the power 0.81, is less than halfway between the exponents that get you 6 and 8. So why is this important? So, well, you have to know that the rate of growth of an exponential function, assuming the base is greater than 1, will always increase. So, for example, consider 10 to the power of 1, 2, and 3. So we are increasing the exponent by the same amount each time, which is just 1, but the actual value increases by a lot each time. So 10 to the power 1 is just 10, and 10 to the power 2 is 100, which is 90 more. And then 10 to the power 3 is 1,000, which is 900 more than 10 to the power 2. So the rate of growth increases as the exponent increases. And by the way, I would recommend you to open, Desmos graphing calculator or just some other graphing calculator so you can graph it yourself and see what I'm talking about here. So if you look at the exponent, then 2 is halfway between 1 and 3. But if you look at the actual values of 10 to the power of 1, 2, and 3, then the halfway point, which is, around 500, is clearly more than 10 to the power of 2, since that only equals to 100. So to get the halfway value between 10 to the power 1 and 10 to the power 3, you have to use an exponent that is more than halfway between 1 and 3. Or put another way, the exponent that is halfway between 1 and 3 is less than the exponent necessary to get the halfway value between 10 to the power 1 and 10 to the power 3. So, looking back at our question, the halfway point between our two exponents is 0.8405, which is greater than the exponent that we care about, which is 0.81. And we just determined that the halfway point between the exponents will produce a value less than the halfway point between your two values. Therefore, we can be sure that 10 to the power 0.81 is less than halfway between 10 to the power of 0.7781 and 10 to the power of 0.9030, which means it is less than halfway between 6 and 8, which means it must start with a 6. And so we can say with certainty that 6 to the power 100 must start with a 6, and that is the second part of the answer to this question. Next is the section 2 question, which says, let I of m comma n be a function of a pair mn of natural numbers that is inductively defined by the following. I of m1 equals to I of 1n, which equals to 1 for any m and n, and I of m plus 1 n plus I of m n plus 1 equals to I of m plus 1, comma n plus 1 for any m comma n. So this might sound complicated at first, or look complicated, I guess. It really did to me when I first read it, but it's actually nothing too different from what you've probably already learned in school. So I'm sure we're all used to seeing this, right? It says that f of x equals to something, and what it means is we plug in a value for x into our function, and it outputs a specific y value. So in this question, instead of f of x, we have I of m comma n. So the only difference here is instead of inputting just one value, we're inputting two. So before we were just inputting a value for x, and now we're inputting two values, one for m and one for n. And then the value of the function is based on what those two inputs are. And of course the question says that m and n are natural numbers, which means any positive integers. So 1, 2, 3, 4, and so on. So if you understand that, then you are able to solve this question, but it is a bit tricky, so don't worry if you can't figure it out right away. So to start, the question asks us to express I of 2 comma n in terms of n. In general, when you get a question like this where it wants you to write a general statement for a function, the first thing to do is probably to just start plugging in values for n and seeing if you spot something. So first, let's just plug in n equals to 1. The question gave us two rules to use to find the value of the function. The first rule says that if m or n equals to 1, then the value of the function is 1. So in this case, we of course have a 1 here, and so this just equals to 1. Next, let's plug in 2. So now we have I of 2 comma 2. For this, we need to look at the second rule. It says that I of m plus 1 comma n plus 1 equals to I of m plus 1 comma n and I of m comma n plus 1. So here we have I of 2 comma 2, which is the same as I of 1 plus 1 comma 1 plus 1. And so if we use the second rule here, then m equals to 1, since n plus 1 equals to 2, and n also equals to 1, since n plus 1 equals to 2. And so we can write I of 2 comma 2 as I of 2 comma 1 plus I of 1 comma 2. And of course from rule 1 we know that these both equal to 1, so I of 2 comma 2 equals to 1 plus 1, which is 2. So let's check the next value, which is I of 2 comma 3. So this equals to I of 2 comma 2 plus I of 1 comma 3. We just found that I of 2 comma 2 equals to 2, and we know that I of 1 comma 3 equals to 1. So this is 2 plus 1, which equals to 3. Now let's check I of 2 comma 4, which equals to I of 2 comma 3 plus I of 1 comma 4. Again, we just found that I of 2 comma 3 equals to 3, so we can see that this is 3 plus 1, which equals to 4. And at this point, you may be noticing a pattern, but just in case, let's check one more value. So I of 2 comma 5, you can see here is equal to 5. So in general, I of 2 comma n equals to n. And so that is the answer to the first part of our question. So next, the question asks us to find I of 3 comma n in terms of n. So once again, we will start by plugging in values of n and seeing if we notice a pattern. So I of 3 comma 1 is just 1 based off the first rule. I of 3 comma 2 equals to I of 3 comma 1 plus I of 2 comma 2. We know from the first part of the question that I of 2 comma 2 must equal 2. So this is 1 plus 2, which equals to 3. I of 3 comma 3 equals to I of 3 comma 2 plus I of 2 comma 3. We just found that I of 3 comma 2 equals to 3. And we know from before that I of 2 comma 3 equals to 3. So this is 3 plus 3 equals 6. And I of 3 comma 4 equals to I of 3 comma 3 plus I of 2 comma 4. We just found that I of 3 comma 3 equals to 6, and we know that I of 2 comma 4 equals to 4. So this is 6 plus 4 equals 10. And once again, you may have noticed a pattern here, but let's do one more number just in case. So I of 3 comma 5, as you can see, equals to 15. Hopefully you can figure that out on your own by now. So let's look at all of our results here. So the answer that n goes up by 1 is 1, 3, 6, 10, and 15. So the question wants us to find I of 3 comma n in terms of n. So let's start by writing all of these values in terms of n, which I did here. So to start, for I of 3 comma 1, it just equals to n. Then for I of 3 comma 2, for I of 3 comma 2, n is 2, and this equals to 3, which means it equals to 3 over 2n. Then for 3, it equals to 2. Then for I of 3 comma 3, it equals to 2n. For I of 3 comma 4, it equals to 5 over 2n. For I of 3 comma 5, it equals to 3n, and so on. So you may notice that the answer equals to n times this first number, and this number increases by 1/2 each time. So let's actually rewrite these numbers a little to make it even clearer. So right here we can say that it's equal to 2 over 2n, since of course 2 over 2 just equals to 1. This is equal to 3 over 2n. This is equal to 2n, but we can rewrite that as 4 over 2n, since of course 4 over 2 just equals to 2. This is 5 over 2n, and this is 3n, which we can instead write as 6 over 2n. So we have this pattern where I of 3 comma n equals to n times this fraction, and the fraction increases by 1 over 2 for every n. So now we have to write this fraction in terms of n. And while you may have noticed that the numerator in the fractions is just n plus 1. So for I of 3 comma 1, the numerator is 2, which equals to n plus 1. For I of 3 comma 2, the numerator is 3, which again equals to n plus 1. For I of 3 comma 3, the numerator is 4, which equals to n plus 1, and so on. And so we can write that the function I of 3 comma n equals to n times n plus 1, all divided by 2, and that is the answer to the second part of the question. Now finally, the question asks us to find the value of I of 5 comma 3. And if you were able to answer the first two parts, this should be easy. And in fact, even if you couldn't find the final answers to the last two parts, As long as you understand how this function works, this should still be a pretty easy question. So to start, we'll use the second rule to break I of 5, 3 down into these two parts. And we still don't know the value of these two parts, so we'll break them up again. So I of 5, 2 equals to I of 5, 1 plus I of 4, 2. Now we already know immediately that I of 5, 1 just equals to 1. And then for I of 4, 2, we have to figure it out, so we'll just break it up again. We have I of 4, 1 and I of 3, 2. We know that I of 4, 1 just equals to 1. And we know from previously that I of 3, 2 is equal to 3, right? We found it in the last question. I of 3, 2 equals to 3. And so I of 4, 2 just equals to 1 plus 3, which is 4, which means that I of 5, 2 equals to 1 plus 4, which equals to 5. So we now have this part done. So now we need to find I of 4, 3. So once again, we'll start by breaking it up. And it equals to I of 4, 2 plus I of 3, 3. So I of 4, 2 we just found right here. It equals to 4. And then I of 3, 3, well, again, we found it previously. I of 3, 3 equals to 6. And so I of 4, 3 equals to 4 plus 6, which is 10. And so finally, we can say that I of 5, 3 equals to 5 plus 10, which is 15. And that is the final answer to this question. And by the way, interestingly, like I said, this is probably the easiest part, but it's actually worth the most marks. The part where it asks you to express I of 2, n and 3, n in terms of n, those are each only worth 5%, but this part is actually worth 10%. So I guess just in general, keep in mind that sometimes, these questions in general might have some very hard parts and some very easy parts, but the marks often don't reflect that. And yeah, in this case, the easiest part of the question gives the most marks. So, don't be discouraged if you can't answer one part of these questions, because you might still be able to get most of the marks. So finally, we have section 3, which says, let f of x equal to e to the x, g of x equal to 1 plus x, and h of x equal to 1 plus x plus 1 over 2 x squared. Fill in the blanks with the answers to the following questions. So to answer this question, you just need to know, just some pretty basic stuff about derivatives and definite integrals. So if you took a calculus class before, even just like, a starter calculus class, then this question shouldn't be too much of a challenge. So first it says that when x is less than 0, arrange f prime and g prime and h prime in ascending order. So to start, we of course need to find the derivatives of f, g, and h. So thankfully this is quite easy if you just know the basic derivative rules. So the derivative of e to the power of x stays the same. So f prime is still just e to the power of x. Next, for g, we just use the power rule to find that g prime just equals to 1, meaning it's a flat horizontal line at y equals to 1. And then for h, we again use the power rule to find that h prime equals to 1 plus x. So the question asks to order these functions in ascending order when x is less than 0. So I suggest drawing a small sketch like this to visualize the problem. So firstly, because it asks for when x is less than 0, it's good to check what these functions equal to at x equals to 0. And you'll see that they all equal to 1, which means that at x equals to 0, all three of these functions intersect at y equals to 1. So we just need to find how the functions change when x goes down from 0. So firstly is f prime, which I drew in red. Because this is an exponential function, it is important to know the function will continue to decrease, but it will never cross the x-axis. It will always be positive, since if you raise a positive number like e to a negative exponent, you will just get a really small number that is still greater than 0. So it'll look like this red curve right here. Next, g prime is just a flat horizontal line at y equals to 1, so it'll look like this green line right here. And finally, h prime is just a line with a slope of 1, so it looks like this blue line here. So pretty clearly you can see from the diagram that g prime is greater than f prime, which is greater than h prime when x is less than 0. Now you might be thinking, well, how do you know that h prime is decreasing at a faster rate than f prime right when x is less than 0? Why can't it look like this, for example? Where at first f prime is less than h prime, but then as x decreases more, it switches and now f prime is greater than h prime. So firstly, we can just reason out the fact that, based on the question given, this wouldn't really make any sense, because the question asks to arrange the functions when x is less than 0. doesn't give a specific range or say only when x is just a bit less than 0. It simply states that for all x is less than 0. So if it were the case that f prime starts by being less than h prime but then becomes greater, then the question wouldn't really make any sense, right? You couldn't order them in ascending order since you can't say that one of these functions is always greater than the other when x is less than 0. But also, if that's not satisfying, there is also a mathematically sound answer. So e to the power of x is special since its rate of change is equal to the function itself. So for example, when x is equal to 0, e to the power of x equals to 1. And so the rate of change of f prime, which is e to the x, is 1. And then as x decreases, the value of e to the power of x becomes less than 1, which means that the rate of change of f prime also becomes less than 1. So immediately below x equals to 0, the rate of change of f prime is a little bit less than 1. H prime, however, which, oh man, you guys, is just 1 plus x, has a constant rate of change of 1 since it's just a straight line. So immediately below x equals to 0, its rate of change is greater than the rate of change of f prime, which means that it is decreasing at a greater rate than f prime is, which means that it is definitely always less than f prime for all x is less than 0. So anyways, we can now order the functions in ascending order like this and say that h prime is less than f prime, which is less than g prime when x is less than 0. And that's the answer to the first part of the question. So the next part of the question asks to arrange f, g, and h in ascending order when x is less than 0. So once again, you should start by drawing a diagram and also by checking the values of these functions when x equals to 0. And in all three cases, oh, sorry, my laptop's acting a bit weird. And in all three cases, they equal to 1. So all three functions intersect at 0, 1. And so we just need to see how they behave when x starts getting less than 0. Once again, f is just e to the x, which is an exponential curve. So it continues to get smaller as x becomes more negative, but it never crosses the x-axis, and it's this red line right here. G is the line 1 plus x, which is a line with a slope of 1. And now what about h? So it's a little bit more tricky because it's a parabola. So the important thing to notice is that the equation for h has plus 1 over 2x squared, which means that the parabola opens upwards. So just like before, we can use the nature of the question to reason this out. The parabola opens upwards, which means as x becomes more negative, it will shoot off upwards. So it has to look something like this as x becomes more negative. So it will definitely be greater than f and g as x becomes more negative. And so because the question asks us to arrange the functions in ascending order for all x is less than 0, it would not make sense for the parabola to go below these two functions and then come back up, because then you would not be able to arrange them in ascending order. So that means it could not be something like, say, this. Sorry, or let me actually draw that again. It could not be like, say, this, where it starts by going less and then comes back up and is greater. Yeah, so it can't look like this, right? Because then you wouldn't be able to order it or you won't be able to order these functions in ascending order. So you can be sure that h must look something like this, where it is always greater than the other two functions when x is less than 0. You can also prove this mathematically like I did for the last part, but to save time, I'm not going to do it here, but you can do it as an exercise. It's probably a nice way to, like a good reasoning question. But either way, we can say that g is less than f, which is less than h, and that is the answer to part 2 of this question. Let me actually label this right here. This right here is h of x. So finally, we have part 3, which asks us to compute these two definite integrals. So assuming you know how integrals work and the basic integral rules, this shouldn't be too hard. Really, the only tricky part are the absolute values, but we actually just did all the work to figure those out anyways. So first is I sub 1. which is the integral from 0 to -1 of the absolute value of f minus g. So if we go back here, we already found that f is greater than g when x is less than 0. And this definite integral goes from 0 to -1, which is, of course, when x is less than 0. So f minus g must be a positive value, which means that the absolute value does nothing and we can just ignore it. And so this is just the integral from 0 to -1 of f minus g. So this is a pretty basic integral. E to the x doesn't change, and we use the power rule to find the next terms. And then you just plug in the values of, so you just use the power rule to find these next two terms. And then you just plug in the values of 0 and -1. I'm not going to go through all of this since it's just arithmetic. You can pause the video if you want to see my steps. And we get this final value of 1 over 2 minus 1 over e. By the way, sorry, sometimes I write, you might be confused. Sometimes I write my ones, sometimes I write them like this, and other times I just write them like this. Hopefully, like, that's not too confusing to you guys. Like right here, it's just a line, but then over here I draw this, little trophy thing, and some people told me that my 1s and 2s look very similar, so hopefully my commentary helps clear that up for you guys. But anyways, finally, we have I sub 2, which is the integral from 0 to -1 of the absolute value of f minus h. So again, if we go back to here, we see that actually this time h is greater than f. That means that f minus h is negative, which means that the absolute value does play a role. What it will do is swap the two functions. So now the integral looks like this. It is actually the integral from 0 to -1 of h minus f. And now we can just solve the integral like normal. So once again, I'm not going to go through all the steps. You guys can pause and take a look if you want to see it, but it's just a basic integral and plugging in some numbers. And so we end up with the final answer, which is 1 over e minus 1 over 3. And so that is the end of this exam. Hopefully this was helpful. I intend to make videos for all of the provided Math B practice exams. So this was 2019 undergraduate, and I'll be going all the way down to undergraduate 2014. I'll also be making videos for the undergraduate physics exams. So if you're in, I think it's Natural Sciences A, I believe, or anyways, if you're writing the physics exam as well, then hopefully those will be helpful too. They should be coming out soon in the next few weeks. And if you have any questions about this exam, you can leave a comment below and I will try to help you. And if you're writing the MEXT exam soon, then good luck and have a great day.